Thanks for coming. My name is Pascal Heus. I'm a data lead at Postman Open Technologies, and my talk today is a little bit about API, but also about other things that go beyond API, about data and open standards. So I hope to entertain you and inspire you to do fantastic things with APIs. So give you a little bit of background as to where I'm coming from, which I think will put things in context. Originally from Belgium, was born there, started as an IT guy, and in the early 90s moved to the US, actually was there for the Belgian embassy. But a little bit later, I started to work at the World Bank as an IT person, and that's where I get essentially involved with data and statistics. And then based on that, I also started to dive into standards, metadata standards, about how can we use technology, how can we use data to improve data management at the national and international level. I did a lot of work in the Africa region, a lot of statistical capacity building with national statistical agencies there. And I got involved with the design of a few standards, in particular, things like the Data Documentation Initiative. And we developed basically technology tools and best practices to improve statistical data management. Later on, family was growing, travel was a bit too much, so decided to keep doing the same thing, ended up creating a small company called Metadata Technology North America. I also ran a nonprofit called the Open Data Foundation for a while, and then doing the same thing, but more working in North America, Europe, New Zealand, Australia, still about adopting metadata standards and best practices for statistical data management. In the meantime, I also moved from the US to Spain and now ended up in Canada, where I live in Calgary, Alberta. Been involved with a few standard setting agencies like CoData, and recently joined Postman literally 3 months ago, and which is why I'm here today and have the privilege to talk to you. And I'm here to talk about data because I've come to love data. Not only because it's an interesting challenge technologically, but also it's critical to drive our societies and the world. And we live in a world where data is all around us. And we have a little problem because I believe the way we handle data is not the way it should be. I call data is not data. And if we go about our planet, we live with digital data around us all the time. We use data for everything. We cannot live without it anymore. Whether it's for personal decision, professional decision, or even decision on the economy, where the planet is going, where our countries are going, data is everywhere. We also have fantastic dreams. We're talking about machine learning, artificial intelligence, and millions of things that we're going to do with data. Most importantly, data is also there to basically measure the state of our nations, measure the health of our planet. Where is our economy going? So essentially, it feeds policymakers with information so they can make decisions. Do we invest in agriculture? Do we need to improve the economy? Do we need to invest in education? And ultimately, it affects all our families. And we have all these fantastic things. We have small data, big data, structured data, and unstructured data. But do we really have the data to back this up in the shape we want to? And the answer is actually, surprisingly, not especially a yes, it's more a no. And the reason for this comes from the fact that data usually looks like this. It's basically a bunch of strings and numbers that is stored in various formats. And when we look at these formats, we have classic text files, CSV files, we have SQL database, we have Excel files, we have Google Sheets, or we have sometimes more specialized formats like statistical packages such as SAS, Stata, and SPSS. And these things have not changed a lot since their inception. I mean, those things actually come from the 60s, 70s, and 80s, and we haven't seen a lot of evolution in the way we actually store and manage data. Sure, we did come up with NoSQL, RDF, and XML, and JSON, and key value graph, but ultimately, you'll figure out that most of the data we analyze, especially for statistical analysis at the national and international level, is mostly rectangular data. And when you look at something like this, there's a lot of things you don't have. If you want to work with data, you need to do much more information than this. There's a lot of missing knowledge here. You got to know what's the code book, what is this data about, where does it come from, what are these codes and numbers, what do they mean? If you're in statistics, how is the data weighted? Where is the data coming from? Why was it produced in the first place? What are the different subjects? What's the time, the geography? What is this all about? And that actually does not exist with the data. It's knowledge that is floating around, and it's actually not always easy to find. There's actually, it's pretty much agreed that like researchers may spend up to 70% of their time not doing research, but actually finding this missing knowledge, this missing information. And it also leaves computer with no access to this information because usually it's not in machine actionable format. So another way to look at it is to take a classic picture. This is the data, information, knowledge, wisdom pyramid. And it's a way to look at what this is all about. We have data at the bottom, and at the top we have kind of this wisdom layer, where the expert and people actually analyze data and do things. And you see there's that gap in between. We actually data that lives in this format, in these files and database. But then we have this thing about the knowledge, the information that we actually need to do research and to effectively analyze data and make conclusions. Because of this, we struggle with this data wrangling problem, and also it makes our computer pretty much blind. So how do we solve this problem? And there's a few things we can do, and some of that has to do with APIs, some of that has to do with metadata. But one thing we have to do is to turn data as we know it today into what I call digital knowledge. And this basically data supplemented with machine actionable metadata or knowledge that is now accessible to computer systems and based on standards. We also hopefully need to complement all that with like machine learning or AI-driven tools to create new metadata around the data. The other thing, once we have that, what we can do, now we're reaching the API level, because now we have all the information in a digital format. We can deliver it through what I call fair open data API. And within the next 10, 15 minutes, you will be familiar with what FAIR is. So we have APIs when we can now discover data, access the data, process, analyze, and publish it, and do all the things we want to do. Now, in order for all that to happen also, we need to foster collaboration between the data custodians, the data producers, the data scientists, and developers, the technologies that actually understand the technology to make all this happen. We need to really encourage knowledge exchange so we can actually achieve our goal. There's a couple of other things I think that need to happen, but will take a little bit longer. One is we have to pass the torch to what I call the next generation of data scientists and data engineer. One of the reasons all these things have not happened so far is most of the managers or people in charge today are not particularly familiar with APIs or technology, and are fairly hesitant to take these steps. I think in a generation or two, when our young generation of developers and statisticians born with technology that completely understand this will be in charge, I think it will be way easier. The other thing I think that needs to happen is that we need a new breed of data management tool. I think we somehow have to move away from the current SQL and text files and even statistical files into systems that are more intelligent, that combine data and metadata and APIs together. But this may not happen, if it ever, for another 15 or 20 years. So I'll touch upon the first 1, 2, 3 steps and see what we can do about that. But the goal is to get to something like this, where this gap between data and wisdom is filled. And there's really 2 steps. And one is to capture this knowledge in what we call machine actionable format or metadata, and then to have open data APIs where all these things become accessible. So the first thing I'm going to quickly go over is metadata. And everybody knows metadata, and also nobody knows metadata. The metadata can have many different definitions. It's all about data, about the data, about the data, and about the data. But at the end of the day, whenever we make a decision, we always need metadata. Like if the food you go buy at your favorite store will come in the cans of the left, you will have a really hard time making a decision about what to buy. We need metadata about what's in the can, what it is about, nutrition fact, and all those sort of things. And my point is basically the way we distribute data today, it looks like the cans on the left. Because basically it's a file, I have really not a lot of knowledge about what's in the can or what to do with it. And the goal here is to basically transform the data can on the left into a data can on the right. All right. So to give you an example of what we're talking about when we refer to metadata around data here, is I'm going to take this simple example, and this is basically a data file. It could be a SQL table, it could be a CSV file, it could be a statistical package. And if you look at this, and I'll tell you, hey, do some analysis, do something smart with it, it's almost impossible, because you really don't know what this is about. No, I'll be impressed if somebody in this room will recognize that this is actually a few records from the US General Social Survey. And it's longitudinal studies from 1972 to 2018. If I want to do some work around this, I need to know what it is about. And actually, every record in here is about adults in the US that are 18 years of age or above, and that's what the study is about. You have this column that called WRK stat, which actually is the labor force status. These little codes, 1, 2, 3, 4, 5, 6, you wouldn't know until you find this piece of documentation that tells you that 1 means working full time and 6 means people at school. There's a lot of information that you need to do something smart with the data. You may have some statistics on the file. You may not know that this is actually version 3. If somebody else will use version 1, they may have different conclusions. This data set comes from NORC, which is actually the organization in charge of collecting and distributing the data. Provenance is extremely important. There's a difference between an official data set that comes from an official organization versus a file that's given to me by my neighbor. So provenance is absolutely critical. You need to know where the data is coming from. And then there's a lot of documentation that is not here. Again, what were the questions that were asked? What are the methodologies around the survey data collection? How has this changed over time and over years? And all this information is actually typically sitting in unstructured documents, PDF, Word, PowerPoint, or even in very volatile storage mechanisms called the human brain. This is in people's head. Then we move away from the organization where they retire, this knowledge disappears. And so all that is actually almost never available with the data. You have to go and hunt for this information. There's also a lot of concepts here, and concepts are extremely important for data discovery. Like, what is this data about? When you try to find data, typically you ask time, geography, and concept. And when you search data, these concepts are extremely important. And there's more to this. Obviously, I'm looking at one data set, but I could look at metadata sets. How do I harmonize? How do I unlink? So we do need this information to actually do something smart and useful with the data. And again, this is almost never available in machine actionable format. So if you're a computer or an application, this is basically what it looks like. And a computer may be dreaming about metadata or about APIs, about accessing the data, but this is often the state we're in today. And it's actually quite amazing what we've been able to accomplish with application and software, and even in machine learning, knowing and understanding that this is actually how computers look at data. Anything else needs to be spoon-fed by human beings and add that to the computer memory. Okay. So the good news is we have a lot of metadata standards to capture information on data. Actually, for the past 2 or 3 decades, a lot of our work has been done in developing standards around many different types of data. And actually, we have many standards, and actually too many standards. So we do have standards, but we need to select a few standards. So we're actually not in the situation on the right, which is kind of a classic cartoon that you may have seen, that we have too many standards that compete with each other. But we just have too many standards to deal with. And it's a challenge. There's actually a website you can go to that will show you a database of all the standards we have identified. There's over 1,600 of them. No, the thing is, not all these standards are mature. Not all these standards are maintained. Some are very domain specific, which is great if you work in that domain, but when you want to generically have open data APIs, or you want to document data, you want standards that go across different domains. A lot of them have limited tools. So actually there might be standards, but standards without tools are really hard to use or even to adopt. And also, almost never do they have an official API. There's a few of these standards have an official API, but often it does not. And I'm putting that in red because this is where information technologies can come into play and make a difference. And this is actually what we want to work on. Now, to solve these problems of the too many metadata standards, there's actually an initiative that just started right now. It's very new. It's called the Cross-Domain Interoperability Framework, or CDIF, which is looking at, say, can we find a set of maybe 10, 15 standards that everybody could adopt and use generically across domain to actually document the data and capture the metadata in machine actionable format and make it available through APIs. And this is actually happening under the umbrella of CoData. CoData is, if you're not familiar with CoData, it's an organization from the Open Science Council that is focusing on data and setting a lot of standards around the world. And there's right now an initiative called the Workfare Program funded by the European Union called Horizon that is funding this work. There are also lots of things happening in CoData around global open science cloud, which I'm also involved in. So this is basically a set of standards that have been identified so far in terms of how do we capture knowledge around data. So most of you are probably not familiar with these standards, and one of the reasons for me to talk about them and list them here is that if you ever work with data, and if you want to go beyond just delivering data, but actually adding knowledge to data, or if you work on Open Data API, these are probably the set of standards you may want to look at. So this is still preliminary work. This is kind of a first set, and I think in the next year or two, it's going to be refined, and I'm probably a few of these standards will be added to this. But this is kind of a good starting point, basically. There's different types of standards. The ones at the top are probably the ones that you might be familiar with one of them, which is schema.org, because obviously Google is using that. But all the other ones are about data discovery, data cataloging, describing the data, whether it's rectangular data or cube data. There's information about provenance, concepts, and all those types of things. There's vocabularies, and even standards talking about licensing and data privacy. So you're, of course, welcome to click to any of these links to learn more about all these standards. But what's important to understand is that there is an effort right now to identify a set of standards to solve this problem. The other thing that I've to touch a little bit about is mentioning FAIR. And FAIR is actually it's an initiative that's been going on for a few years and is now widely recognized by most data producers, data custodians, data archives, researcher communities, and data scientist communities around the world as kind of the agreed reference. And the goal of FAIR is to make data findable, accessible, interoperable, and reusable. So it's for both user and machine, and particularly targeting machine, because that's our gap right now, it's our weakness right now. So FAIR is first a set of principles that each of these, FAIR, findable, interoperable, accessible, reusable, as a set of principles. And basically what it says is everything should be identifiable. If I put something out there, I need to have globally unique identifiers, so actually I can find the information and I can reference it. There's a lot of talk about how to capture metadata using some of the standards we have mentioned, and about covering all these problems on making data open, making data accessible, making data useful. So FAIR is a big thing. I'm not going to go into too much detail about FAIR. There's a lot of information out there. But a couple of things that you may want to hear about, for instance, something called a FAIRification process. Or do I take data and turn it into FAIR data, which is basically, again, capturing the knowledge, capturing the metadata, make it in machine actionable format, and then deliver that through open APIs and various mechanisms. There's something called a FAIR digital object, and this is really what we want to look at when we talk about data of other things, is we shouldn't just put data out there, we want to put FAIR digital object on there, which is something where the data exists, but also can be identified, can be made available in open formats, and comes with sufficient metadata, so it actually makes it useful. And again, if you want to know more about FAIR, obviously I cannot cover FAIR in a short presentation, but there's obviously the Go FAIR website where this all starts, and there's a lot of additional information there where you can dive more into FAIR. Now, what is the role in this for people attending this conference our goal is that box in the middle, which says API. Because a lot of work has been done in terms of defining standards, defining best practices, defining what is a digital object, defining what is metadata. But the weakness at this point is the technology. We need more tools, we need infrastructure support of this, and mostly we need APIs, which is also one of the reasons I joined Postman, is to make that a reality. This is actually where we can make a difference in the data space and make data accessible and open and usable. So there's also the idea of why are we not doing this? And there's actually a study that was conducted a few years ago about what is the cost of not doing this? What is the cost of not having FAIR data? And it was conducted just in the European Union. And the numbers that came out of there were quite staggering. It basically says there's about at least 10 billion euros a year that are lost by not having FAIR data, plus probably another 16.9 billion in unquantified elements. And most of this amount is basically goes into time that people waste trying to solve all these data problems, as well as storage problems. Data gets duplicated in many formats and goes over the network, and it's really hard to find. But these numbers are huge, and this is why there should be a sense of urgency that we do need to transform data into fair data and use open APIs to make it accessible. So as I said, it's 1.2 or 3 million an hour, which is quite, it's 1.5 million euro by the time I'm done with this presentation. And so it's not something that we should wait. It needs to happen as quickly as possible. There's a lot of wasted resources because of the lack of fair data. So finally, how do we make all this happen? And it's all about collaboration and education and working together. This is the gap that I'm dreaming of filling, and why I'm talking to you, and I'm talking on both sides. But on one side, I realize we have communities such like the information technology community, where we have great developers, great data engineers, we understand the cloud, we know what our APIs, and we understand technology. But actually, we may not understand data very well. We may not understand what data is about, how it is produced, what are the challenges, what are the weaknesses, and what are the problems. That knowledge resides on the other side, which is more data producers, data scientists, even some of the other users. So they have an understanding of domain standard of data, but they don't have an understanding of technology. And what we really need to make happen is to bridge these two communities. We actually need to have a dialogue between mostly private sector and public sector and academic sector. So we actually can bring data and technology together. There's a wide range of places where this can happen. Again, I've mentioned CoData. There's a lot of organizations such as the Research Data Alliance, obviously GoFair, there's the Open Data Institute. We are a space where we can actually make all these things, turn all this into reality. So at the end of the day, the reason I'm mentioning this is what can we do here as API designer, API implementers, or information technologists in general. What I would like you to walk away from this talk is like next time you plan to make data available or you work with data, just think about these things. Don't just publish data. Think about publishing fair, open data. Don't just connect to a database and a file and deliver it. Think that you need to deliver digital knowledge. So actually this data becomes discoverable, findable, usable, and accessible. Integrate this type of concept and potentially some of the standards we've talked about today into your API design, because that's how we're going to make a difference. That's how we're going to make this happen. If you're in machine learning, in AI, first thing that this will really help you strengthen your machine learning applications, but also think about how machine learning could help create new knowledge around the data. Or we could have artificial intelligence around data management systems so we can improve the knowledge. And then please become part of this. Try to become part of this work with the scientific community, with the data producers, join global efforts, understand, educate yourself on some of these standards and best practices, because this is the only way I think we can see we're going to realize our dream of really a data-driven world, but also to unleash the capabilities of today's information technology. So, so the conclusion, we do need to upgrade our data. Data as we have it today works, but we could do much better. We have to turn it into digital knowledge. We do have the standards and the techniques for this, but we need to actually build the tools, build the APIs, and mainly manage the change, because change management at the end of the day is one of the biggest challenges. We need to come together for this, information technologists and data scientists. And this is not just about standards and technologies, but at the end of the day, it directly impacts the world. It's about people, it's about societies, and at the end of the day, it's also about the well-being of our planet. So I hope this inspires you a little bit to look at data differently. Next time you think about open data API, add this little piece of knowledge to your portfolio, and this is my mission in life. So if you have any questions, suggestions, please don't hesitate to contact me through Postman or just email or any other means. So thank you for your attention. All right. Any questions? I see a hand raised there. not particularly, actually. It's, this is also, I think, where I want to emphasize the importance of metadata. The data is actually not always there, or the data may not be accessible, which is an interesting problem. You'll find that actually most of the interesting data is, I call this open data. It doesn't mean it's public data, right? So metadata will help you discover the data, but then you may need to go through a few steps to actually be able to access the data. So the data is not always there, or at least it's not directly accessible through your API. You may need to go through a bunch of layers to actually be able to touch the data. Some of that may be for privacy reasons, for connectivity reasons, for storage reasons, and stuff like that. But this is also where this metadata element comes into play, because the metadata may be out there, so you can discover it. And just knowing that the data exists is you know, it's a big piece of the puzzle here. So, but again, a lot of these things that we do today with data are essentially manual process. It's a user burden or data producer burden, and a lot of things could be done essentially handed over to machines and code and applications. We do that all the time in many different sectors, but somehow when it comes to data, and of course I'm focusing a lot on things like, you know, social data and health data and agricultural data, or even sometimes scientific data, but these data sets are way harder to find and deal with, and there's a lot of gaps that needs to be filled. There's obviously a big difference between being in the technology world where people don't understand these things and do that all the time, and being into the academic or public sector, which really needs help, honestly. They still have quite a bit of work to be done. So. Two hands. Sure. I think the biggest challenge are the tools and the APIs. See, because like a lot of agencies that we talk to, like you completely understand technology and API, but I would have questions about what is an API, right? That's the first question I get. And I think educating some of the stakeholders there about API, about technology, about how to use it, is I think one of the biggest challenges today. And of course, change management, but that's true for anything we do in life. I mean, there's always a resistance to change. A lot of people say, oh, we have to do all this, but God, it makes me uncomfortable. But that's a generic problem. But I think tools is the problem. And what I really think there's been a lot of progress done in terms of describing metadata and data, and all the information is there. But we actually need to make it happen. And to make all this information available to application, the missing piece is the API. Even the same thing, if all this metadata existed, it still will not be accessible to application because the APIs are not there. And this is why I think this community, the developer community, the API community, can make a huge difference by simply bringing some of these principles in designing or open data API, or data API in general. That's really what it is, I think. That's a piece of the puzzle for sure. So the question about basically what the semantic web comes into play here, and I think discovery is definitely one of them. Is simply also sometimes you can use semantic web technologies to establish common vocabularies, common classification. Because right now data is not there, but you can type keyword. Doesn't mean it's. I said if I give you a data file, you may not even know what it is about, and connecting the dots. So I think the semantic web plays a big role for findability, for discovery of data, for sure. Interestingly, a lot of the communities there are very RDF oriented, very semantic web oriented. There's actually an extremely push for RDF, and one of the things we're trying to educate people in that space is about actually most of the world use JSON and REST, and not everybody likes to hit a Sparkle endpoint, right? Because the academics is very semantic way than Sparkle. So, which is fine. I mean, there's nothing wrong with RDF, but it's nice to have a layer on top that makes it more open and accessible to what most developers would use, which would be JSON. Or JSON. JSON LD can be tricky though, because it's kind of a, yeah. We are talking about that with Kin not so long ago. I like to use JSON LD for certain things, but again, if you just throw JSON LD out there, it can become very confusing because it's like RDF, right? And unless you're into it, it's not trivial to use. So that's why I like better, you know, like more traditional REST JSON type of API that any developer can understand, for sure. Yeah. Oh, thanks. All right. Well, thanks for coming. Appreciate it. And that's it. I'm an email away. I'm a Slack message away. This is a space where we can make a difference. So hopefully, it's just, as I say, it goes a bit beyond technology, and it touches a bit many different things. And there's a lot of interesting work to be done. But it's fun. I promise you. If you start. Again, I just want you to walk away with some of these concepts, and hopefully, I said, next time you look at a data set, you look at it a bit differently. So. Thanks for coming. Appreciate it.